to my channel. Today we will be solving a Geeks for Geeks practice problem. This is by the name counting elements in two arrays. You can find it and it is of easy level problem. So first we will see the problem statement. So basically two arrays will be given, okay, and it may be of same or different size, and its size will be given like mn. Its size will be given and the array elements will be given, okay. Basically we have to count like number of elements less than, like for the first we have to return an array list, okay. We have to return an array list of the same size as that of the array number of elements in the array 1. And what we have to check is like for the first element 1, it's how many elements are there in the array 2 that is less than 1. So 1 2 3 4, so here it is 4, the first one, okay. Now second we will check for the second element of the element of the array 1, that will be 2. Then we'll be checking for the 2, so how many number of elements are there in the array 2 that is less than this element, okay. So 1 2 3 4 5, so here we are returning 5, okay. Now then next comes 3, okay, then next come 3. So here how many elements are less? 1 2 3 4 5, 5, so here it is 5, okay. Now next we'll check for 4, okay. Now 1 2 3 4 5 6, okay, 6, all the elements are less than or equal, okay. Then we'll check for 7. 7 is obviously greater than all the elements, so it will be like a whole size 6. 9 will also be greater, so 1 2 3 4 5 6, okay, so 6. And this we are returning these values in data structures called array list, okay. Okay, and basically it's not necessary that both the array will be of same size, okay. Since m and n, two arrays, different array of different size, it will be given, okay. In the question it will be given, we don't have to find it. Even if it's not given, the both two arrays are given, we can find the size of the both arrays, okay. Now what will be the size of the output? It will be equal to the size of the array 1, okay. 1 2 3 4 5, okay, 1 2 3 4 5, yeah. Now first we see the brute force approach, that will be first coming to our mind, okay. Now first what we can check it, think it of like two pointers, okay. One will be pointing to the first array and then second will be pointing to the second array starting onwards, okay. Then we will be checking, okay. First we'll take two pointers, okay. I is equal to 0 and I should be less than m. M is the size of the first array, okay, and I should be plus, okay. Now then I'll be taking the second array, okay, 0, and j should be less than n and j should be plus, okay. Now we'll keep a count, okay, int count, and initially it will be 0, and if my ARR of 2, okay, the content of second array of j, that is the pointer of the second array, it's less than equal to array 1 and pointer is I, okay. If it's less, then we will count plus is equal to 1, okay. And if this is successful, okay, we have to make an array list first for storing the values, array list, okay, integer values, okay, and this will be list is equal to new array list, okay, yeah. So we'll be storing this list dot add, we'll be storing the count value in the array list, and finally at the end we'll return the list, okay. At the end we'll be returning the list, okay. Now we should compile and see. Some error is there, okay. J, okay, int, I've not initialized it. Now we should submit and check for all the test cases, okay. Okay, 382 till 382 it has passed. Okay, 393. Okay, time limit exceeded. Okay, now this is not the optimized solution. Okay, this is not an optimized solution because we are running the whole array, both the arrays at a whole length m plus n times. Okay, so to optimize it, we can just do it like we can sort the second array and we can check if it's like exceeding with the particular array value, then we will not check it further. Okay, so we can optimize in that way. So arrays dot sort, I'll make use arrays dot sort. Okay, and this will be array 2. Okay, and if I am getting like a else part, okay, else part, if I'm going to else part, break out of the loop and I'll not check it further. Okay, like for if I'm sorting this area elements, okay, so one will be coming here and two will be coming here. Okay, so when I'll be checking, if I am like getting a greater value, so I'll not be checking further elements, I'll just break it over there only. So it is a bit of optimized, it's not fully optimized, it's just slightly optimized solution. So we'll run and see. Okay, submit. Let's see how many test cases has been passed in this. Okay. Okay, it got passed. Okay, it got passed fully, or it got passed. Okay, wow, means 342 out of 342 it got solved. Okay, but still it's not an optimized solution. Okay, I don't know how it got passed, but yeah, maybe that okay. Now this is not still more optimization can be done, like if we are checking for a linearly, we are checking elements, but if we will go for a binary search, then it will be more optimized solution. Okay, so this solution is also optimized one, but I'll show you the next element also, next method also I'll show you. Okay, so we'll take this. Okay, now this approach that I am going to discuss with you, it's basically make use of a binary search, and the previous one was a linear search. Okay, now for n I is equal to 0 and it should be less than, okay, I should be less than him and I should be plus plus. So basically this first pointer will be as it is because we are checking for each and every elements, so we can't do anything with this first pointer. Okay, and this arrays dot sort, not arrays dot sort, we are not going to sort it. Okay, and then we will make the array list. Okay, array list. Okay, show. Okay, now this is done. Okay, now I'll search binary. Okay, search binary, we'll make use of it. Search binary, search binary, and this arr 1 of I, this I'm going to search in my whole array arr2. Okay, and the size is given n. Okay, and this should return me some index value that I will store it in the count. Okay, count, and should initialize this first. Okay, uh, okay, this will be stored in the count, and then count I have to insert in the array list. Okay, so basically this binary search function will return me some index value till where the element is getting matched. Okay, and then I will add it to the list, add it to the list. Okay, this count value. Okay, and finally I'm gonna return this list. Okay, now I'm left with just one function I have to declare. Okay, and integer value, it's the return time and it's static, so even I have to put static over here. Okay, static binary search, and this is a just an integer array. Okay, this is not an array, this is just a single element, so I'll give it a name k, and just to make it short I will give it like a integer array arr, and I'll keep the size as n itself. Okay, and here what I'll do, I'll go for a binary search. So binary search we have to like declare two upper and lower limit. Okay, so lower limit will be 0, and upper limit will be the size of the given array minus 1. Okay, size of the array is given, okay, n minus 1. Okay, then I will run this till my lower is less than equal to upper. Okay, I will run this till my lower is less than equal to upper, and at the point when my lower will be greater than the upper, and that while will be terminated. Okay, and then we have to find the mid. Okay, it's same like a binary search, whatever the technique we are like, it should be sorted also. Okay, this binary search will only work for a sorted array. Okay, so here we should sort, and I'll pass. Okay, arrays dot sort. Okay, arrays dot sort order 2. Okay, binary search won't be working for an unsorted array. Okay, array should be sorted. Okay, then only we'll be checking for a upper and lower. Okay, so two conditions. Okay, for this array is sorted, and I have to and this lower should be less than equal to upper. These two conditions should satisfy for a binary search. Okay, for this lower and upper we have declared, and then mid we will take it out, like lower plus upper and whole divided by 2, like some average kind of value. We'll take it out and we'll check for the middle value. Okay, now if my ARR of mid, if my ARR of mid is less than equal, if my less than equal to the given element k, then if it's less than, okay, then if it's less, so we'll increase the mid value. Okay, so mid is equal to mid, okay, not mid plus 1, mid plus 1, and not mid, see, if my ARR of mid, if this is my ARR of mid, so, and it's less than equal to k, so lower one I will increase and put over here. Okay, so lower one will be increased. Okay, and else okay, what will be coming to else part, when my k will be greater than the ARR of mid. So if my k it's greater, like for checking 1, if I'm coming over here, that will be residing 2 will be residing over here, so I'm encountering 2, so my upper should move to 1 less than the mid. Okay, so my upper should move to mid and less than the value. Okay, so mid minus 1. Okay, and finally the point that it will be greater. Okay, so 1 will be mid plus 1. So if I am checking for just one first value, okay, 1, so my 1 will be here and 2 will be here. Okay, so first time it will come over here, second time it will come over here, third time it will come over here. Okay, whenever it will be coming here, so it will be like a mid minus 1. Okay, and mid minus 1. Okay, and it is increasing one more times. So okay, yeah, got it. See, the time that the lower upper will be less than the lower, okay, then it will be terminated, this whole loop will be terminated then. Okay, but lower will be 1 greater than the required value of index, and it should be and it's okay to pass the lower, because we are storing the in from 0 1 to 3, but we have to return one greater value. So it's okay if my lower is one greater than the required index value. Okay, so yes, we pass the lower value. Okay, if you're not getting like why I'm passing the lower, since see, if my lower will be the point when my lower will be equal to upper, okay, so it will come over here, it will increase the mid value, lower value by 1, then it will go over while, and it will for terminating this, for coming out of the loop, and my lower is greater than the required index value. Okay, so uh, as it will come out of this loop, it will come out of this loop, and its lower value is one greater, but it's okay if it's one greater, because we are like storing the index value from 0 1 2 3 4. Okay, it should be counting should be one starting from 1, so it will neutralize that thing. Okay, so we should just check it if it's correct or not. Okay, it's correct. Now for all the test cases, okay, yeah, got compiled. Okay, it's got compiled. Yeah, 342 test cases out of 342 passed. Okay, so this was the two approaches that I have explained, and it is like a most frequently asked interview question. So in the interview, you are first going to tell the brute force approach first, and then you will be telling the optimized solution. Okay, and yeah, practice it well. You'll find this problem in the Geeks for Geeks. Okay, and it's easy level question, and it's very easy. You can do it on your own also. It's very easy. Okay, thank you. And if you have any of the problem or any other approach in solving this problem, do put it in the comment section. And yeah, do hit the subscribe and the like button. Thank you.